Alright, so this is the equivalent resistance worksheet that I told you I was going to give you answers over. So first you'll need to have your worksheet in front of you so you can have the diagram, because I'm going to redraw some of these. So first off, let's do number one. If you redraw it, you'll have the battery like so. And as it comes out of the battery, it goes through resistor 1, which has a resistance of 2 ohms. And then it comes to a junction and splits. And then it goes through resistor 3, which has 6 ohms. Or it can go through resistor 2, which is 4 ohms. And then it comes back together and comes back around to the battery. Alright? So on your chart, the first thing you want to find is our total resistance. Our total resistance is going to be the sum of all the resistances, but I have a parallel portion and a series portion. So first I need to find the equivalent resistance of this section right here. And so I'm going to do that down here. The equivalent resistance of this section is going to be 1 over R is going to equal 1 over 6 plus 1 over 4. Alright, and if I do this in my calculator, I'm going to do 4 to the minus 1 plus 6 to the minus 1. That's the 1 over 4 plus 1 over 6. And I get an equals, and then I do the inverse of that, and that gives me 2.4. So the resistance of this section is 2.4 ohms. That's the equivalent resistance of that whole section. So let me go ahead and erase that. Now this 2.4 ohms is in series with this one. So now I just add those together and get a total resistance of 4.4 ohms. Now the question, the paper tells you that the battery is 120 volts. So if I know the total resistance is 4.4, I can find the total current to be using Ohm's law, V equals IR. My current is voltage divided by resistance. So I take my 120 divided by 4.4, and I get a current of 27.27 repeating, so I'm going to call that 27.3 amps. So there's my current. Now as you look at this, the current coming out of the battery is 27.3, and it has to go through this resistor. That's resistor 1, so the current through 1, it has to go through it, so it has to be all of that because it's in series. So that's 27.3 amps also. And so the voltage drop for resistor 1 is V equals IR. So I take my 27.3, so 27.3, and multiply that by my resistance, because V equals IR. So multiply that by 2, and that gives me 54.6 volts. So that's the voltage drop here. So I start with 120 volts. I lose 54.6 volts. So that means this parallel portion has to have a voltage that makes up the rest of it. Because remember, the loop rule says that the sum of all the voltages have to equal 0. So this voltage plus this voltage has to equal that voltage. So the voltage here is going to be 120 minus the 54.6, which is 65.4 volts. Now that is the resistance, the voltage of this whole segment. So if I were to stick a voltmeter here and a voltmeter lead here and a voltmeter lead here, that would measure the potential difference between those 2 points, which is the same regardless of which path you go, and so you get 65.4, which means the potential difference of 3 is also 65.4 because they are in parallel to each other. So my current through those two resistors is determined by Ohm's law. Again, V equals IR, so R equals V divided by I. So my voltage is 65.4, and I divide that by the resistance, which was 4. The resistance of resistor 2 is 4 ohms, so that's 16.35, and then 65.4 divided by the resistance of this one, which was 6, is 10.9. Now you should see that 16.35 plus 10.9 adds up to 27.3-ish. There's a little bit of difference because of rounding, because these are not clean numbers, but there you go. That's the process for number 1. Okay, so you can rewind, pause, whatever. I'm going to move on to number 2. Now, number 2, again, let's redraw the circuit a little bit. This one, you come out of the battery and then it splits. And one branch goes through resistor 2 and resistor 3. The other branch goes through just resistor 1. And then it all comes back together and goes around back to the battery. So I'm actually going to look at it this way. Essentially, this is what you have. If I were to erase those and draw this like this, and then put my battery there, this is the same thing. So that's 120 volts. And resistor 1 is 2 ohms. Resistor 2 is 6, sorry. Resistor 2 is 4 ohms. And resistor 3 is 6 ohms. So now, there's my circuit. And so I've got the same R total. I want my I total. And then I want I1, I2, I3, and then delta V1, delta V2, delta V3. Okay, so let's find our equivalent resistance first. Once again, this is a parallel circuit. And so we know that our equivalent resistance is the 1 over R is going to equal 1 over R1, which is 2, plus 1 over all of that. These two together are in parallel with this one. So these two together are in series, so we add them together. So that's going to be 1 over 10, because 4 plus 6 is 10. So I use my calculator again. I do 2 to the minus 1 plus 10 to the minus 1 gives me 0.6, and then I do the inverse of that to get R as 1.666 repeating. So my 1.66 repeating ohms, or you could write it as 1 2/3 or 5/3. Let's do it that way. Let's do it as a fraction. Because if you type it in, alright, so 5/3 ohms. If you round that off, then you'll end up with numbers that are way off later. So we're going to leave it as a fraction here. So my total current is V divided by R. So that's 120 divided by my total resistance of 5/3, so that's divided by 5 times 3, because you invert and multiply. So 120 divided by 5/3 is 71.9 repeating, so 72. So I'll call that 72 amps. Okay. And so I now know my total current. I also know that this resistor, resistor 1, is in parallel with the battery, so its voltage drop has to be the same as the battery. And if I have 120 volts, and 2 ohms of resistance, then my current has to be 60 amps. Okay, so I have 72 amps that come out of the circuit, 60 amps go this way, which means 12 amps go this way, and all 12 of those amps have to go through both of those resistors. So this is 12 amps and 12 amps. Alright, and now I know that I have these two voltages here, since they together, this voltage plus this voltage, have to equal the voltage of the battery. That's 120. So 12 is resistor 2, so 12 times 4 is 48, and 12 times 6 is 72, and 48 plus 72 does equal 120, so there's my answer to number 2. Alright, moving on to number 3. This one is the one that has gotten most people, given most people the trouble, the most complicatedness. So I'm going to, again, redraw it. I have my battery. It comes out of the battery, and I'm going to have it go ahead and go around a corner here. And then it splits and goes through resistor 1, which is 2 ohms. Alright, and the other branch goes this way through resistor 4, which is 8 ohms. And then after it goes through the 2 ohm resistor, it splits again and goes through the resistor 2, which is 4 ohms, and resistor 3, which is 6 ohms. And then that comes back together and comes back to the battery. So this is the same circuit as what you have on your paper. It's just drawn a little bit differently, but it's the same thing. So now you should hopefully be able to see that. Let's find let's do our table here. We have I total, and then we have I1, I2, I3, and I4, and delta V1, delta V2, delta V3, and delta V4. Now, the few things that we know that this is 120 volts still, and I know that this 8 ohm resistor, which is resistor 4, is in parallel with the battery, so it has to have the same voltage as the battery. Okay, so that helps out. Helps me know that one. Now let's find our equivalent resistance, and this is where it gets a little bit complicated, because first I need to find the equivalent resistance of this little part right here. 1 over 4, that's going to be the inverse of 1 over 4 plus 1 over 6. So here's what I'm going to actually type in my calculator. My equivalent resistance there is going to be 4 to the minus 1 plus 6 to the minus 1, all of that to the minus 1. So let's put that in the calculator with parentheses and everything. So that's 4 to the minus 1 plus 6 to the minus 1, all of that to the minus 1. That gives me 2.4. So this is 2.4 ohms. Now this 2.4 ohms is in series with that 2 ohms, so that whole branch here is 4.4 ohms. So that whole part right there is 4.4 ohms. And that's basically, this is number 1. And then we just added something else to it. So remember, the total resistance of number 1 was 4.4 ohms. Same circuit right there. We just added another branch to it. So now my equivalent resistance for the entire circuit, I'm going to do my 4.4 to the minus 1. So 1 over this, plus 8 to the minus 1, and then take that to the minus 1. So that's still using the 1 over R plus 1 over R plus blah 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 equation. So I'm going to do 4.4, or sorry, parentheses. I'm going to do 4.4 to the minus 1 plus 8 to the minus 1, close parentheses, to the minus 1, gives me this funky long decimal. I'm going to round it to 2.83 ohms. Well, we'll say 84 to round it properly. All right, 2.84 ohms. So if my resistance is 2.84 ohms, what's my total current? Well, I take my 120 volts and I divide by my 2.84, and I get a total current of 42.3 amps. So what I just did my voltage divided by my equivalent resistance, and I get that many amps. So that many amps comes out of the battery. I have 42.3 amps out of the battery, and at this point it splits. Now I know if this is 120 and my resistance is 8, 120 divided by 8 is 15. So I have 42.3 amps come into this junction, 15 amps come out of the junction this way, which means the other amps have to go that way. So I take my 42.3 and I subtract 15, and that gives me 27.3, which means 27.3 amps has to go this way. Okay, which means I1, or my resistor 1, which is this guy, has to be 27.3 amps, because all of that 27.3 amps has to go there, and then when it gets here it splits again. We'll get to that in a second. But now that I know the current here and the resistance, current times resistance is voltage. So I take my 27.3 and I multiply it by 2, and I get 54.6 volts. Now, I know that this whole branch has to be the same voltage as my battery because it's in parallel, loop rule. Alright, so if this resistor has 54.6, then this resistance or voltage here has to be the difference between 120 and 54.6. Alright, so I do 120 minus 54.6, which is 65.4. So my voltage through the 4 ohm resistor, resistor 2, is 65.4, and since it's in parallel, this one gets the same voltage because it is in parallel. Now that I know the voltage and the resistances, I use Ohm's law to find my current. So my voltage divided by my resistance, 65.4, divided by my resistance of 4, is 16.35 amps, and then 65.4 divided by my resistance of 6 ohms is 10.9 amps. Now 10.9 plus 16.35 adds up to 27.3-ish. Again, it's a situation of rounding. So there you go, that's number 3. Number 4 is exactly like the one I did in class as the first example. So let's look at it real quick. This one's going to go fairly quickly. Alright, so I have my battery. I'm not going to redraw this one because the way it's drawn is perfectly fine. I have my 2 resistors, and then I have another resistor here. This is 120 volts. I need to find my total resistance. Well, resistor 1 is 2 ohms, resistor 2 is 4 ohms, resistor 3 is 6 ohms, and resistor 4 is 8 ohms. So my equivalent resistance here is, again, the 4 to the minus 1 plus 6 to the minus 1 is the 2.4. We've done this multiple times. It's the same situation, so that's 2.4 ohms. Okay, so my equivalent resistance of this part is 2.4 ohms. Well, I have this parallel portion is in series with these two. So I have 2 plus 2.4, which is 4.4, plus 8, my total resistance is 12.4 ohms. So that means my total current is 120 divided by 12.4, which is 9.7. I'm going to go ahead and round that to 9.7 amps. So if I have 9.7 amps coming out of the battery, it has to go through this one. So the current through 1 is also 9.7 amps. And once it goes through this, it comes back together and it has to go through 8 and go back in. So the junction rule tells us all of the current coming in has to equal the current going out. So that means current through 4 is also 9.7 amps. Okay, so if I have V1, V2, V3, and V4, I can now find my voltages for 1 and 4, because my voltage is my current times resistance. My current is 9.7. My resistance for 1 is 2. So that's a 19.4 volts. And this one is 9.7 amps times its resistance of 8. And so that's 77.6. So I have 120 volts. I lose 19.4 volts. Here I lose 77.6 volts, which means the difference is how much I lose in the parallel portion. So I'm going to do 120 minus 19.4 and then minus 77.6, and that's going to give me 23. So my voltage is 23 volts here. Well, that's the same as this one because they're in parallel, so they're both 23 volts. So I2 and I3, I can now use Ohm's law. 23 divided by 4 is 5.75 amps, and 23 divided by 6 is 3.83 amps, and you add that together, you should get pretty close to 9.7. Again, I rounded things off on these problems, so it's not exactly right, but that's the process that you go through. Start with the smallest portion and then use those equations for the loop rule and the junction rule that I gave you and work it all out. It's just a process. Redrawing it helps if you need to, but make sure that you are ready for your test.